Good morning, students. I am your biology teacher going to teach another concept in the same topic, that is osmosis. In the last class, we saw osmosis, its definition and an experiment also, isn't it? Yes. Today we are going to see we are going to start with one question, that is how long osmosis continue. How long osmosis continue? How long the osmosis continue? It is a process of movement of water, isn't it? But where it stops, or whether it stops or continuously it occurs, that is the question. For that question we are going to find the answer. Okay, come on children, I'll explain that. So take this as a cell. This is a cell. Inside the cell, the water molecules are there. The you please take imagine that 20 water molecules are here inside the cell. Okay, so 80 water molecules are outside. In its outer environment, it is 80 water molecules, whereas inside the cell 20 water molecules. This is the plasma membrane. This is the cell. Consider this as a cell. Inside 20 molecules and outside 80 molecules of water. How long the osmosis takes place? Osmosis takes place, see, osmosis should continue until the concentration of both the sides become equal. Osmosis should continue until the concentration of both the sides become equal, till it gets isotonic on both the sides. Isotonic means on both the sides equal concentration. That is, but here inside 20 and outside 80. But when it becomes equal isotonic, when it becomes 50 and 50, 50 50, 50 50, inside and outside 50 50 must be there. So it wants to become 50. So it must take 30 water molecules from outside. Yeah. So when 30 water molecules from outside, that is the extra 30 water molecules are outside, when it comes here, it will get the 30 and it becomes here minus 30, both become 50. Both become 50. We will till it attains the 50 50 water molecules on both the sides. In this example, the osmosis takes place. Okay, so when it reaches 50 50, 50 50 on both the sides, then it become isotonic solution, then osmosis stops. Got it? Yes, that is, till then the osmosis takes place. This is the natural occurrence. Okay, will it be there in all the circumstances? No, there are some other conditions are also there. In such conditions, even the concentration difference is there. Here 20, here 80. Sometimes osmosis stops. Under what condition it happens? Let us see. Okay, so here osmotic, that is osmotic pressure. That is what is called osmotic pressure. What is osmotic pressure? Osmotic pressure is the minimum pressure exerted by the solution to stop osmosis. Minimum pressure exerted by the solution to stop osmosis. Which is the solution? That is the sugar solution found inside the thistle funnel is the solution. Which is the solvent? The water found in the beaker is a solvent. So from where it stops, that is the pressure is created here. That pressure is equal to that of the pressure exerted by the water to enter inside. To enter inside, it exerts certain pressure. From here also, in certain condition, a pressure is created. When these two become equal, the osmosis stops. I'll explain you. Okay, so if the column, that is the thistle funnel column, is raised up and continuous passage of water occurs to get a isotonic solution. Continuous passage, it is rising up, it is rising up, it is rising up, it is rising up. If it goes, what happens? The weight of the water column, that is sugar solution column, will increase. Water enter inside and its weight will increase. When weight increases, it creates a pressure. the pressure will exerted on the semi-permeable membrane. When the pressure is exerted on the semi-permeable membrane, that pressure will be equal to the, when the pressure is equal to the pressure exerted by the water to come inside. That is, the solution's pressure as well as the solvent pressure become equal. Osmosis stops even though the concentration is not equal. Even though the concentration is not equal. That is what is called osmotic pressure. So what is osmotic pressure? Then the next definition you must study. That is a minimum pressure exerted by the solution to stop the movement of solvent, that is water. Or you can say like this: minimum pressure exerted by the solution to stop osmosis. That is, it is stopping the movement of water molecules. Okay, that is what is called osmotic pressure. To describe that, there is another experiment. The very same experiment, a slight modification is there. The verticil funnel, that beaker, water, sugar solution, everything same, but you must insert a airtight piston. Piston, you know, in the syringe and all we can see, no, like that one airtight piston must be kept over this with some weight. Okay, when this piston is acted on this sugar solution, it gives some weight. The weight is giving some pressure to the semi-permeable membrane. When it is giving some pressure, this pressure is equal to the pressure by the water exerting upward. Here a pressure is exerted downward. Here a pressure is exerted upward. Then it becomes equal. When it becomes equal, osmosis stops, even though the concentration difference is there. Okay, in naturally, what happens when it becomes 50-50? When it becomes both sides become equal. Isotonic, when it gets isotonic, it stops. That is the natural occurrence. Okay, but we can stop osmosis by giving some pressure, exerting some pressure. That is what is called osmotic pressure. So what is osmotic pressure? Osmotic pressure is the minimum pressure exerted by the solution to stop the movement of solvent, to stop osmosis. Okay, that's children. This is a small concept. Just only one page is there in your book. You just go through. Okay, bye.